Week 6, Water. Earth, the water planet. Earth is often called the water planet because about 70% of the Earth's surface is covered with this stuff. That's not the only reason, though. Living things, people, animals, plants, you name it, are mostly water. You and I, in fact, are made up of approximately 65% water. But because we see and use water so much, we don't usually sit around thinking about how special it is. It's just 2 parts hydrogen and 1 part oxygen. Nothing to it, right? If we think like a scientist, however, we can understand how and why we all depend so much on that one little molecule, and why water is one of the first things we look for when exploring other planets like Mars. Where there's water, there might be life. On the other hand, if we don't find any water, we won't find any life either. Water is important to many different branches of science. For example, geologists know that moving water changes the surface of the Earth, and as a result, pay close attention to where it all goes. So geology is the study of rocks. Geologists are scientists that study rocks. Meteorologists, scientists that study weather, know about the water cycle, know that the water cycle is what drives weather patterns and affects climate. Hopefully you remember the difference between weather and climate. Weather is what's happening outside right now. Climate is like the average over many, many, many years. So North Dakota, people often think of a cold climate during the winter. We do have nice summers, but biologists know that all living things need water for life. Chemists know that the water molecule is a unique structure that allows it to easily dissolve most other substances. Environmental scientists focus on the impact that humans have on water resources, since we can't live without it. Likewise, doctors know that water is necessary to keep us healthy and clean. Astronomers know that Earth is the only known planet that has water in such abundance in all 3 forms: solid, liquid, and gas. As you can see, water is so important on Earth that we really shouldn't take it for granted. This week, we'll take the plunge and look at where we find water on Earth. We'll review the water cycle and take a look at how people use water and learn ways to conserve water. Get ready to dive in. STEM, bottom of the ocean, top of the sanctuary charts. We live in a gorgeous country that has it all: towering mountains, waving grasslands, sandy deserts, and even beautiful oceans. Much of our land is privately owned, but the government tries hard to protect as much as it can. It is important to protect the land and water for us to enjoy, but we also need to protect the wildlife sanctuaries, places set aside for wildlife, so a sanctuary is a safe place. One small slice of this national treasure, about 16 miles off the coast of Georgia, is Gray's Reef National Marine Sanctuary. A reef is a long rock or sandbar that lies beneath the surface of the water. Gray's Reef is a sanctuary because it is rich in marine, or ocean wildlife, that scientists are eager to protect and study. Marine biologists refer to a seafloor that can support lots of invertebrates, animals without spines, as a live bottom. Gray's Reef has a rich and diverse population of wildlife that lives on a rocky shelf 60 feet below the surface. With a large amount of wildlife living there, it's almost impossible to see the rocky bottom in places. Divers and scientists sometimes call it a carpet of living creatures. Do you want to learn more about the ocean sanctuaries in American waters, including Gray's Reef? You can check out that website if you would like. Water resources and the water cycle. Just look at a globe. You can see something obvious about Earth's water. 97% of it is saltwater found in oceans, only 3% is freshwater, and 3/4 of that freshwater is locked in huge polar ice caps. A tiny bit of water is found in the atmosphere as water vapor, and just 1% of the Earth's water is freshwater that humans actually use. There are 4 places where we find Earth's water. Oceans. All of Earth's oceans are really one connected ocean. Although we've named the different areas of ocean water, all of them form one big body of salt water. Again, oceans make up 97% of Earth's water. Ice. Polar ice caps in the Arctic and Antarctic regions contain almost all of the fresh water on Earth. Glaciers are massive ice chunks moving over the land, and icebergs are huge chunks of ice floating in the ocean. Rivers and lakes. This is where you will find most of the fresh water on the surface of the Earth. The Great Lakes in the United States holds 20% of the Earth's fresh water, so 20% is 1/5. Below the Earth, there's far more fresh underground water than there is on the surface. When rain or snow falls, it seeps into the soil and into cracks and layers of rock underground. This fresh water is called groundwater. We can dig wells to pump groundwater to the surface to use. Most groundwater is very clean, and it has been purified by layers of sand and rock, which act as a natural water filter. Not all water is liquid or ice. Water also exists in a gaseous form as water vapor. Liquid water changes to a gas when water molecules on its surface gain heat energy and evaporate. Besides evaporating from oceans, lakes, and rivers, water also evaporates from the surface of soil and puddles. Plants give off water vapor through their leaves in a process called, I hope you remember it from last year, transpiration. All of this evaporated water enters the atmosphere as water vapor. Water vapor is a gas, so it wants to spread out and rise. Water vapor rises in the atmosphere until it reaches the upper atmosphere where the surrounding air is colder. Some of the water vapor loses heat energy and condensation takes place as the water vapor changes to liquid around tiny dust particles in the air. These liquid droplets gather together to form clouds. As more water vapor condenses, the cloud grows heavier. Eventually, the wind in the cloud must fall back to Earth. This is called precipitation, and it can be rain, snow, sleet, or hail. Once water returns to Earth, there are 3 possible places it can go. It might fall directly into the ocean, where it may eventually evaporate again, continuing the cycle. It may land on the land. It may fall onto the land. Here, some may evaporate again immediately. Other water may flow down the land into a river or lake. From there, it may eventually evaporate again. So this water cycle stuff will help you also with your studies weekly about soil and water. Other water that falls onto land may trickle into the soil and rock to become groundwater. It may remain underground for a long time before it eventually travels to a river or lake or is pumped to the surface by humans. Once it's on the surface, it may evaporate again. Everyday science. Earth filters its water. You know that Earth recycles its water in the water cycle, but did you know that Earth also purifies its water? It's true. Think about a sponge. When you pour dirty water through a sponge, the holes trap the large pieces of dirt. Only clean water flows out of the bottom. Earth, soil, and rock act just like that sponge. When water travels slowly through Earth, soil, and rock, it's called percolation. The longer that water takes to slowly percolate through the Earth, the cleaner it gets. When humans take away plants and rocks from Earth's surface, they take away Earth's ability to purify water. Smooth paved surfaces force precipitation to flow quickly to a river or lake. This is called runoff, and it's a real problem. When runoff flows down streets and parking lots, it carries the oils, chemicals, and trash from the surface. All that dirty water flows right into the creeks or rivers. Earth didn't have time to clean it. Preventing runoff is an important way we can take care of our water resources. This week's question, can we take salt out of ocean water? Our planet is mostly water, but almost all of it is salty, so we can't use it to drink or water plants. Isn't there some way we can take the salty ocean water and convert it to fresh water so we can use it? The process is called desalination, and it's not a new idea. In fact, there are many desalination